Welcome back. In this video, we're going to take a look at doing a hypothesis test. Now, there's some links between hypothesis tests and confidence intervals. So let's start with house prices version 9, where we'll see some of these numbers again. So just, take a minute to refresh, make sure you've got version 9 loaded. While you're doing that, I'm going to save this as version 10. All right. So now I'm going to add a new worksheet, and I'm going to call this Hypo Test Part A. And I'm going to make column A wider so we can see more things better. And we're going to even make things a little bit bigger for a little bit easier to see. So first we start out with our hypotheses statements, if you will. And here, I want to find out if the mean housing prices are statistically different. So my null hypothesis is that the mean is equal to 200, and my alternative, H1, is that the mean price is not equal to, which we kind of represent in a very informal way as a less than, greater than. And then the values, because we'll use the values in column B later on. And just justify that. And that's our key thing. We're looking to see if there's statistical evidence that the mean housing prices are different than 200. And like in the confidence interval, we have some inputs that we need. The first is usually we start out with an alpha level. That is our tolerance for making a type 1 error. We call that recall from the videos. And that will be 0.05. We also have our sample size, which has not changed. That's N, 39. We have our sample mean, often called X bar, and that was 208. So we can see that we're comparing 208 here to our hypothesized value of 200. Perhaps we want to see if prices have changed since last year or something. Then, of course, we have a sample standard deviation, often called S, and that was 67.3. And then if we jump back over to the confidence interval for mean, we see that, we had a lot of those before. So maybe we'll call this, I should say, hypothesis test for a mean, part A. Now, I'm going to calculate out the standard error of the mean. If you recall, this was simply sample standard deviation, which is 67.3, divided by the square root of the sample size. And so that's about 10.78. I don't need quite so many decimals. I'll leave it at 10.77. I kind of like the way that looks. Okay, and there's the formula for your reference in column C. The next thing I'm going to find is the critical value of T, or maybe better said as the critical T value. So this will tell us how far away from our hypothesized value of 200 we need to be in terms of standard deviations. So here, we're going to use a function in Excel. So I go formula, insert function. It's under statistical, and it's toward the bottom. We get into the T's. t.inv2t. And this function in Excel was made specifically for things like this, where I want to find the t-value based on our probability alpha in B5 and our degrees of freedom, which is going to be our sample size -1. And you see that that is 2.024-ish. And again, I'll put that formula in the next cell. And I'll jump back over to the confidence interval for mean, where you see that that's our calculated t-value, same formula. So we have a lot of these overlaps, and that may help your understanding. So now that we've got our critical value of t, let's get our test statistic t-value. So the test statistic is how far away our sample mean 208 is from 200 in terms of standard deviations. But don't forget, our standard deviation here is the standard error of the mean. So here the formula would be equal to our 208, don't forget the parentheses, minus the 200, which is simply 8, numbers work out pretty nicely, divided by our standard error of the mean. Again, when we're dealing with a sample size of 39, it's not just the standard deviation, it's a standard error of the mean. And I can check that down to, don't need quite so many, maybe 3 is good. So here, we've got our test statistic, which tells us that we're less than 1 standard deviation above the mean. Now, our critical value tells us that we want to be at least 2, or a little bit more than 2 standard deviations away from the mean. And that could be positive or negative because of the fact that we have a not equal to. We're equally interested in being far away from the mean on a positive or a negative side. I specifically started out with a positive example because it's a little bit easier to understand on the first go around. So we could make our conclusion as to whether to reject or not based on this, but I'm going to go a little bit further and calculate the tail area for the t-value above. That is, how much area is to the right of 0.742. And we can use another function in Excel, statistical, and this one is the t-distribution. There it is, t-dist. And here we put in the x value, which is our test statistic. Our degrees of freedom is going to be our sample size -1. And for cumulative, we want 1. Now, the problem with this is, which is all fine, this gives me the area to the left of this value, and I want the area to the right, so I subtract that from 1. And I do not need all those decimals. So I'm going to use my handy format painter to fix that. Don't you hate it when stuff like that happens? There. So now, I could even go, no, that's good. So now, get that formula for you. And the next thing is, we need to multiply that by the number of sides. So what I mean there is, maybe I don't need all that. Because it's a not equal to test, we have to account for both sides here. Both sides equal to, not equal to. And now we get this creates the p-value. Great. Don't need that many decimal places either, so we'll tighten that up, and we'll put that formula into the next column. And now we're in good shape. So now we have a p-value of 0.462. We have a test statistic that is much lower than our critical value. So our main conclusion here is do not reject HO. Because, let's start with the p-value, because the p-value of 0.462 is not less than alpha of 0.05. Also, the test statistic value of 0.742 is not greater than 2.0244. Therefore, there is, again, I'm kind of emphasizing the nots here. There is not evidence that the mean house price is different from 200,000 at the 0.05 level of significance. Let me save that because I finally got it in good shape here. So that's our inference. Is this, while it's $8,000 more, it's not statistically higher than 200 in order for us to conclude that the housing prices may have changed from a previous year's level. But let's go a little bit further now that we have this great model, and I'll save it as this as our final conclusion. But let's say we wanted to see if it was different than 190. So now 208 is quite a bit higher than 90, and we're down to a p-value of 0.103. Here you can see the p-values work so well. And then I could go even further and take that down to 185. And all of a sudden now our p-value is less than 0.05. Our test statistic is greater than that. And so now the 185 value is different enough than 208 that we would conclude to reject. Now the interesting thing there is, if we go back to the confidence interval for the mean, we see that the 185 is below the lower limit. And so there's a relationship that if the hypothesized value is outside the confidence interval, and the confidence level is 95%, which mirrors the 0.05 alpha level, you should have a conclusion to reject. So that's a big takeaway. And of course, it's great that you can build some models like this, and I'm going back to the 200 here. You can build models like this to do all the heavy lifting for you. One final inference, just to reinforce it, is that p-value becomes so important. So back at that level of 200 where we originally started, that's really how the p-value is calculated. And just you can see this display where we looked at this value, the area above the test statistic, and because it was a two-sided test, we looked at the lower level, the opposite side, and so that's why we multiplied the tail area by 2 to get this p-value, and that's how it's created. I wouldn't spend too much time worrying about how it's created, because as I said in the videos, you want to, you can take it from any of the sophisticated software that's out there. Thank you. We'll see you in the next video.